Okay, well today we're going to be talking about the CAPWAP join process to the wireless LAN controllers. If you saw the last class I did, we were talking all about the discovery process, so those APs booting up, discovering a whole bunch of controllers to possibly join to. Now the next step here is going to be actually joining up to the wireless LAN controllers. So if you didn't see that one, you should be able to find it on our YouTube channel for iPexpert, so definitely go ahead and take a peek on that one if you haven't seen it. This is being recorded, so if you want to re-watch it again or have other people watch it, that will show up on our YouTube channel as well, so you will be able to view this again in the future. So the AP join process, this really starts after, my notes, after the discovery phase is completed. So just a review of the discovery phase. When an access point boots up, it's going to load up its OS, and then at that point it's going to move into a discovery phase where it's going to build a list of wireless LAN controllers to try and reach out to. So the join process starts after that list has been compiled. So we have a list of one or multiple wireless LAN controllers to possibly join up to. So that's kind of where we're picking up the story here. So we have this list of controllers already built out. Now what we discover is the management IP address. So all of our AP in this process here is going to be reaching out and trying to discover controllers by their management IP addresses. So the first thing it's going to do, it's going to send out a discovery request. Discovery request to every single wireless LAN controller that it compiled in that list during the discovery phase. So it's going to send each one a discovery request to the management IP address that it discovered. And it's looking for a response. So the wireless LAN controller sends back a discovery response. In that discovery response, we're going to have a number of pieces of information that this access point is going to use to figure out, who should I be joining up to. So some of that information included in the discovery response from the controller. It's going to have the controller's name, controller type or model. So is it 5500 or 2500? The number of licenses, and the number of current APs. So how many APs do we actually have currently on here? Does it have the master controller flag set or not? It's kind of just a yes or no. And finally, we have an IP address of an AP manager interface. So we discover the management IP address, but ultimately when we join up to a wireless LAN controller, we're joining up to an AP manager interface. Now in older controllers, we always had separation between management and AP manager. So like on a 4400 or the older WISM controllers, there was a management interface, and then there was an AP manager interface, one or more AP manager interfaces. On newer controllers, so pretty much anything currently selling today, 2500s, 5500s, those other ones, the management interface inherited the ability to be an AP manager. It can or cannot be, it's optional, or we can have additional multiple AP manager interfaces. So depending on the controller you're on, this AP manager IP address might also be the same IP address as the management interface, but technically it's the IP address of an interface that has the AP management functionality on it. So at this point, the AP has sent out this discovery request to every controller that it discovered. All the controllers that receive these should respond back with a discovery response, including all this information here. Once the AP has received all these replies back, Now it needs to actually try to join up to a wireless LAN controller. So how does it figure out which wireless LAN controller it should try to join first? Well, there's a priority to everything that happens here. So for the AP join priority, if I can spell right, priority. So the first, really, 3 things it's going to try to join. If you hard code a primary, secondary, or tertiary controller on the AP itself, it will try to join those first. Primary, secondary, tertiary. So like I said, these are hard-coded on a per access point basis, so this is something that wouldn't really occur on a fresh out-of-the-box AP unless you actually went into the AP and primed it with either a primary, secondary, or tertiary. Typically we have these, once an AP has joined up, that's usually when we start configuring these things. Although some people have a really streamlined process where they take a brand new out of the box AP and actually have a provisioning process that they go through with that. But we can do that either through the GUI, through the CLI. So hard-coded primary, secondary, tertiary. If we don't have one of those, or you're not able to join up to one of those, the next one is going to be a master controller. This is just any wireless LAN controller that has the master controller option enabled. Typically you would use this, you would most likely have one of these in your network, and it's usually done so that any brand new APs that come up just sort of sync in to this master controller. Once they're there, you go and configure them for the appropriate primary, secondary, tertiary controllers, and then they never really use the master controller anymore unless that was supposed to be the controller that they're on. Or if you only have, a couple controllers, and you have maybe a controller per site, and well, you wouldn't even use that. Most of the time, it's for this provisioning process of any brand new AP just goes there. Then I know any APs that are on this master controller just need to be further provisioned. Most of the time, it's not the controller. That stuff just stays on forever. Last one we have is going to be the least loaded controller. And it's not the one that hasn't had the most to drink. It's the one that has the least number of APs in relation to the number of licenses that it has. So this is on a percentage basis. So let's say we had 2 controllers that, it wasn't primary, secondary, tertiary, it wasn't a master controller, so we're at this kind of last one here where it's the least loaded. So let's say we had WLC 1 has a total of 10 APs, and it has 100 licenses, so this is 10% loaded. WLC 2, let's say this was maybe the DMZ controller, but for some reason the AP actually discovered it on accident. It has no APs on it, but it only has 12 licenses. Well, that's 0% loaded. So technically, that's the winner. So if you're ever trying to load balance out your APs, pay attention to what controllers they're actually discovering, because if you aren't using primary, secondary, tertiary, and you aren't using master controller, you're just allowing them to discover up a bunch of controllers and just sort of load balance themselves across it. It's going to load balance, again, based off of this percentage. It's not the number of available licenses, it's just the percentage of used licenses. So that's one place where you can kind of get yourself in a little bit of trouble if you're not paying attention to what's being discovered. And I guess really the tiebreaker, once we get down kind of to the bottom, if everything is the same, it's the first to respond. So whichever discovery response that it received first, if everything else is equal, that's the one it's going to attempt to join up to. So let's show you real quick how to configure a few of these things, just so you understand if you haven't actually seen the configurations for these. So the first configuration, primary, secondary, tertiary. A few ways you configure this. Let's show you in the GUI first. So I have my controllers up. I already have some APs joined up. So let's go to a controller where I have some APs. Do I have one here? Yep. All right, so if you go and click into the access point that you want to configure, again, this is a per access point configuration. We have a high availability tab up on top. And we can configure our 3 different controllers. So I could say right now I'm on controller 2, so I'll leave this guy to be the primary 10.10.112.10. If I want, I could have a secondary controller, WC1, 10.10.111.10. I'll just leave it at that, 1 primary, 1 secondary. Now this is going to be saved in the flash of the AP, so the AP will remember this upon across reboots. So that's the one beauty of this configuration is it's static. So regardless of what else is happening, whether our discovery mechanisms, the dynamic ones, whether it's DHCP or DNS or whatever it is, whether those are working or not, it always remembers a few of these controllers to join up to. So that would be through the GUI. Let's show you how to do it on the CLI. So maybe you want to have a process where you'd stage these up before they even joined up to the network. So if we go to an access point, we're on the same LAP one that I just configured in the GUI here. So right now I'm on the console connection of the access point. If I wanted to configure the same thing from here, it would be CAPWAP AP, and we have primary base, secondary base, tertiary base. So same type of configuration as just through the CLI. So I could say primary base, what's my controller, WLC2, what's its IP address, 10.10.112.10. Now you'll notice that the IP address is optional. If we go back to some older code, before you were only able to specify the controller name, so you actually had to still discover it, the IP address, through one of the normal means, DHCP option 43 or DNS or whatever it is. Once it discovered it, got that discovery response back, which included the controller name. If it matched the name that you specified, then it would join up to it as its primary. Fortunately, in newer code, now we don't even need to discover it. We can hard code the IP address so it can immediately go out there, send the discovery that way. So you can go primary base, secondary base, tertiary base. There's one other option, CAPWAP AP controller IP address. This is the same as doing the CAPWAP AP primary base, except we just configure an IP address. We actually don't configure the name. So because we don't get to configure the name through this command, most of the time I try to fall back to primary base or secondary base, tertiary base. If you want to validate it in the CLI, show CAPWAP client config. And we'll see it towards the beginning with these MWAR names and MWAR IP addresses. So primary, secondary, tertiary there. So that's how you can actually validate if it's actually configured through the CLI. But most of the time we're just doing it in the GUI, and you can see it pretty quickly in the GUI there. So that would be configuring a primary, secondary, tertiary. How about master controller flag? This is a global setting per controller. Go to the controller menu, down to advanced, master controller mode. And it's just a checkbox. Check the box, apply. Perfect. So now when I send back the discovery response, master controller flag will be set to yes. And as long as the APs don't have a primary, secondary, tertiary, they're all going to funnel into wireless LAN controller 2 as long as they discovered it. And the last part there, we really don't need to, there's no configuration there. It's just a tiebreaker at the end with the least loaded controller. So that would be the join priority. So up to this point, we discovered our controllers. We sent a discovery request. We got our discovery response back with lots of information. All this information here, name, model, licenses, master controller flag. Once we receive all of those, we're going to analyze them. Okay, which one am I going to try to join first? Primary, secondary, tertiary, a master controller, or a least loaded controller? Now, once I've figured out, okay, what controller am I going to join, the join process really starts in earnest. So now I'm going to send a join request to my controller of choice. In that join request, it's going to send an X.509 certificate. So let's kind of draw this out just a little bit here. So we have our AP, wireless LAN controller. I want to do this real simple. We have one AP, we have one wireless LAN controller. So initially, we sent a discovery request, and we got a discovery response. Now we're going to join it. So we send a join request. With the access points x.509 certificate. So this is almost ETLS-ish, where we have the AP sending its certificate to be validated by the controller. When the controller sends the join response, sorry, my phone's buzzing at me, with the controller's x.509 certificate. So there's a certificate exchange in both directions that each side has to validate. Now when this AP attempts to join the controller, when it sends its certificate, the AP can actually use one of 3 different types of certificates that it sends to the wireless LAN controller. So the default certificate that it's going to send is a manufacturer installed certificate. That's what's going to happen probably 99% of the time today. So let's just write these out here. AP cert types. Number 1 would be the MIC, or manufacturer installed certificate. Since I think it was 2006, Cisco has installed manufacturer installed certificates in all their access points, so that when the AP tries to join up to a wireless LAN controller, it's already got a built-in certificate signed by the Cisco CA. The controller already has the CA cert to validate the certificate presented by the access point. So it makes it really easy. Very smooth process, and something that most people don't even think about or maybe even realize that's happening. So that was pretty much from 2006 or newer. So anything that's pretty much an 1131, 1242 and newer, definitely anything that's AO2.11n has a manufacturer installed certificate by default. Usually where we don't have a manufacturer installed certificate is when we get into the second most common type, and that'd be a self-signed certificate. Typically we run into self-signed certificates when we do an autonomous to lightweight migration. So we bought this autonomous AP like forever ago. It's maybe like a 1230, or some of the very first 1131s I believe might also have needed these. When we do that migration from autonomous to lightweight, well, autonomous APs don't really need a cert because they're not using it for anything. But when we move to lightweight, it does need to present a cert, so we need to create one if it doesn't have one. So since I don't have an actual CA to provision a certificate down to the access point with, it just creates its own. So self-signed certificate is just one that the access point came up with on its own. The only problem with self-signed certificates is that the wireless LAN controllers have no way to really validate it because it wasn't signed by a CA that the controller knows about. It was just created on its own, so essentially the AP is its own CA in this case. So when we do self-signed certificates, the controller actually needs to be told every single self-signed certificate that an AP could present to it. And we'll get into how that's configured in just a little bit. The last one, and I honestly don't know any companies that do this, but there obviously are some out there, it would be a locally signed certificate, or an LSC. This could be on any type of access point, either a newer access point, older access point, it doesn't really matter. What this is rather than say I'm going to use, rather than use the MIC or whatever built-in certificates on the AP, I actually want to provision my own certificates and push those out to my access points. So I would have my own PKI infrastructure with my own certificate authority, create certs on that, and push it out so that when the access point joins up to the controller, it's presenting a certificate signed by my CA, not Cisco's CA. And then I can really control what APs are allowed to join up to my controller, because I'm only going to maybe allow these locally signed certificate access points to join up to my controller. Again, hardly anyone ever uses this. but that is a type that could be in use. So it's going to present one of these 3 certificates to the controller. The controller needs to validate these, so if it's a MIC, it's going to pretty much work automatically. If it's a self-signed certificate, we have to tell the controller about every single self-signed certificate that could be joining up. And if it's an LSC, we need to make sure that we've installed the CA that created the certificates for these access points. So let's kind of show you where we would configure the stuff for accepting these different certificate types. On our controller, we are going to security and then AP policies. So here we have the default configuration. We're going to accept any manufacturer installed certificates or MICs automatically. So that's just going to work right out the bat. If I want to accept these other certificate types, SSC or LSCs, I have to actually check the box to allow them. If I want to accept SSCs, LSCs, turn these on. Otherwise, they're just going to be flat out denied. They're not even going to look at it any deeper than the fact that it's not a MIC, so tough, I'm not allowing you to join. Now, if we have a self-signed certificate, we do need to add each one. So you would click on Add up on the top right here. Choose a self-signed certificate. And you need to put in the MAC address of the access point as well as a key hash. Now, how do we know what this key hash is supposed to be? Well, there's 2 ways of doing this. One is ideally you use the tool, the Autonomous to Lightweight Migration tool. And what that's going to do on your behalf, when you run the tool, you actually specify a controller as well as credentials to log into the controller with. The tool is going to migrate the access point from autonomous to lightweight. It's going to create the self-signed certificate as a part of this process. And then it's going to log into the controller that you specified and pre-populate an SSC entry. So it's going to do it for you as long as you use the tool. If you don't use the tool, now you got a little bit of work ahead of you because you got to figure out what that is. And there's no just show command that you can run on the access point for this. You actually have to use debugs. And once we get into troubleshooting, we'll show you what that debug command is so that if by chance you are using SSCs and you either lost the hash or you forgot to use the tool and you don't want to have to play around with a bunch of steps of undoing it, redoing it, you can find what that hash key is. So this is where we're choosing which cert types we want to allow. And again, if it's a self-signed certificate, we do have to pre-populate every single one of those on the list in order to accept it because it's not signed by a CA that we can use to validate. Okay, so if we go back here. So the AP sends a join request. The wireless LAN controller validates the cert. Wireless LAN controller, as long as the cert was validated, sends back a join response with its cert. The access point has to validate that. Once this entire process is done, now the AP has actually finally joined the wireless LAN controller. Now there's still a couple extra steps that we need to do to finally get this access point fully up and running. First thing it's going to check once this is joined to the controller is, am I running the same code that the controller is running? If there's a code difference, the access point needs to download the correct code so that it can be in sync with what the wireless LAN controller is doing, either in either direction. Either it needs to downgrade or upgrade, just depending on what's going on. Most of the time we're upgrading to new code every once in a while. So that way we know every access point on the controller always is using the same code that's on the controller. So we don't have to worry about any feature discrepancies or anything like that. If by chance the access point is running different code, it joins up, starts downloading the image immediately. Once it's downloaded the image, it actually has to boot up with the new code. And at that point, it's going to start this process all over. It's going to discover, try to join up, do these join request and response and so on. Once we've joined up and we do have the same code, the last step really is the wireless LAN controller is going to push out configuration to the AP. So at that point, it's going to configure the access point. The access point will get all of the WLANs and appropriate configurations. And at that point, it's up and running and should be servicing clients at that point. So that's the overall flow to the join process here. Just a quick rehash. We've discovered a bunch of controllers by their management IPs. I send discovery request to every single controller. The controller responds back with a discovery response with lots of information, including an AP manager IP address to join up to. When I join up to the AP manager IP address that I learned in the discovery response. The controller validates the AP cert, sends its own cert to the AP validates the controller. We do any code upgrades, downgrades, and finally configuration is pushed down to the access point. So, what could possibly go wrong in this process? Well, there's quite a few ways that this could kind of fall apart from start to finish. So, let's talk about troubleshooting a little bit, unless anyone has any questions about clarifications of this join process. No? Okay. So troubleshooting the join process. We'll assume at this point, at least, that the discovery is working. We've discovered controllers to try to join up to. So we're assuming that the APs are at least sending, at a minimum, the discovery requests to the controllers. If you want to know how to troubleshoot the discovery phase, where we're trying to build that list of controllers, look at that last class that I did in terms of the discovery process, and that'll show you how to troubleshoot all those methods. A note on that one, I had problems doing a debug when I was in that class. I figured out the problem shortly afterwards. I was trying to debug on the wrong controller, so that's why I wasn't getting any output. So if you watch that class again, and you'll notice that I was on the wrong controller. So tip, always be running stuff on the correct controller. All right, so troubleshooting. Most of the time I'm going to start just looking at some cursory information, namely logs happening on both the controller and the access point, as well as the AP join stats. That's usually the first place I'm going to go. So, black please, there we go. So if you have access to the AP console port or the AP logs, you can look at that. There's usually some helpful information you can see there. Now in a real life deployment, most of the time we don't just have access to that because we don't have console ports, terminal servers plugged into all the console ports, and most of the time Telnet SSH is turned off. So that's not always easily available to us, and that's fine. If you don't have it easily available to you, just skip that step for now. We can look at controller logs. Oftentimes both traps and syslogs or just regular logs. Sorry, spelling and speaking at the same time I don't always do well. And finally, wireless LAN controller AP join stats. So oftentimes you can start getting clues here. You might flat out see the answer in these, or you might at least start getting ideas about what might be happening. How far along in the process are we at least getting? Did we get a discovery response? Did it attempt to join? Did we get a response back? Things like that. So the AP logs, I'm normally just looking at it in the console. But in the controller logs, I'll show you the two places I want to look. So what if Prime is part of the network? The join process is Prime is really invisible, I guess, to the entire join process. Now, it could be used as a place to consolidate a lot of these logs. So if you didn't want to dig into the controllers to look at the logs, you could be looking at that in Prime. But in terms of the process of joining, Prime's totally out of the picture. It's more of at best, it would be useful as a troubleshooting tool to look into some information with. Okay, so where are some of these logs in the controller? Under management, the trap logs are going to be under SNMP trap logs. Now honestly, this is my favorite place to look for logs because most of the trap logs are written in a little bit better English. You can actually understand kind of what's going on in the trap logs. So you can look in here. If you want to look in the more like syslog kind of logs or buffered logs, you'll see under logs, message logs. And you can see it in here too, but you'll notice not always the easiest to read, but a little bit more detailed at times. Those are two places, but honestly, the best place to go is under Monitor, Statistics, AP Join. This is going to keep information about every single access point that either is joined or at least has attempted to join this wireless LAN controller. So you can see right now I have one access point joined, and then it's remembered a bunch of other access points that they haven't joined themselves, but they've at least sent a discovery request. So if we click into the access point in question, for this you would need to know the AP's MAC address. But once you know the MAC address or the IP address, if you knew that as well, you can kind of figure out which AP it is. If you go in here, you can see information, for instance, about the last AP join, but each phase we get some information on. So here's the discovery phase. So I received 2 and I sent back 2. So that means, at this point we have connectivity. It received the packet and it sent it back, so we know at least it's communicating back and forth with each other. It sent a response. Okay, how about the join? So now, how many join requests did I get? How many responses did I send back? If there was a problem, it would actually tell you the reason for the last unsuccessful attempt. Here's where we can start getting some good information, both for the discovery phase up here, as well as for the join phase. Configuration phase, this again pretty much happens once it actually has joined, so most of the time it's not a problem once we get to the configuration stage of the game. Last error summary, so you can get some information there too. So a lot of good information here. They're going to either tell you flat out what the problem was, or at least start giving you some clues. So really great place to go here on the controller. Otherwise, look at some of those logs. That's going to get you going for sure, and it might even solve your problem for you right there, or at least tell you what the problem is. Once I've got through these steps though, then if I still am not quite sure what the problem is, now I have, for me, I guess, one of two methods that you could go down once we've done step 1 here. Now step 2 is going to be, to me, you do one or the other for the most part, unless one of them's not working. You could get into the debugging route, where you're going to run debugs and dive deep and try to look, at the entire process and what might be going right, what might be going wrong in there. No doubt you can definitely find out what the problem is through debugging, but how much work are you having to do that, and how much data are you having to sift through to try to really narrow down what the problem is? The other route for me is the cheat sheet route. I kind of like this one because honestly I'm not a huge fan of debugging, just because it's a lot of data sometimes to sift through to figure out what's going wrong, whereas there's only so many reasons why a join wouldn't happen. If I just sort of have a cheat sheet of what all those reasons are, most of the time I can actually jump through the most common problems real quickly, and as I'm doing that, I'll probably spot the issue. So let's talk about debugging first. A few commands that if you need to go down that more detailed road, maybe that's your fallback if the cheat sheet method doesn't work. What debugs that we can be using to help us out for this join process? Most of the debugs are going to be on the controller itself. So if I go to CLI of a controller, so what debugs can we do? Well, first, depending on the controller, we might have a whole ton of access points currently on the controller, and we only really care about one. So if we want to kind of pare back, what debugs that we have to sift through, let's target, the AP that we want to debug. So if we do a debug, MAC address, and we can specify the MAC address of our AP. Again, we need to figure out what the MAC address of the AP is, but usually that's not too hard. You could look in the ARP tables, so if you knew the IP address of the access point, look at that. If you knew the port that the access point was on, look at the CAM table and see, okay, what MAC address is on this port. If you can actually get to the access point itself, you can do, I believe, just a show version, I think might have it in there, or a show interface definitely would have it in there. A few different ways, but just go ahead and specify it, and it's in the format of character, colon. So every 2 characters, it's a colon separated. I won't do this because I don't know the MAC address right now. That's going to filter and show you, it should only show you debugging for the specific AP you want. Now let's actually do the debug commands that might be helpful for you. So there's going to be 2 debug CAPWAP commands. We could do debug CAPWAP events enable. And this is going to show you more generically just any sort of CAPWAP interaction or a kind of event happening. So more of a high level. This should allow you to kind of watch the process. Here's the discovery request, there went the discovery response. Here's the join request, there went the join response. Lots of that type of information, so you can either see where, how far did it get along the process, or you might actually get some helpful information even beyond that. Another one that you can do is CAPWAP errors. So when something actually goes wrong, show me that information when we actually have problems in the CAPWAP process. The last one that's going to be really helpful is debug PM PKI enable. This is specifically for certificate stuff. Since we have that certificate exchange during the join process, both the controller validating the client or the AP certificate and vice versa. This is going to help show if there's any issues with that. So those 3 debugs on the controller are probably going to be your best friends. And look at that, we already got some stuff going on. Obviously, we can get a lot of stuff happening here. So if you need to stop the debugs from happening, debug disable all. And actually, if you just type in DE space D, that does it as well. Sorry, D space DI, that would do it. So if you ever need to stop it, debug disable all will kind of stop it and sort of get you back and going in your CLI here. On the access point, most of the time we don't have access to these, or at least easy access. One thing that you could do on the access point itself would be, get into enable mode here. It should be debug CAPWAP client event. So here you'd be able to see, that discovery request, discovery response, join request, join response from the perspective of the access point. So, this is going to help you know, okay, I know I sent the discovery request, but I never, on the controller, I never saw it receiving it. So, okay, we probably have some sort of a connectivity issue here. Or I got the join, I sent the join request, but something fell apart on the response, so it was probably something in relation to that. So, something you can do here. Now, I'm not going to go over every single failure scenario because that would be almost impossible to try to drill through all these. But these are debugs that you could be using. And I'll give you some documents that you could be looking at too to sort of show you what some of this debug looks like when things are going wrong as well as when things are going right, so you can kind of see that as well. So those are the debugs that you can most commonly use to figure out what the issue is. Now, personally, I like the cheat sheet method. So let's go ahead and talk about all the main reasons that a join wouldn't be working. Oh, sorry, recorded. Yep, so absolutely being recorded for further use. So a cheat sheet method. Let's talk about the main ways that the join process fails to work. So, cheat sheet. And here, basically, all I do is I just go through the list, check them all, and eventually, usually I find what the problem is here. And it only takes a couple minutes, honestly, to go through. So usually you can get to the heart of the problem pretty darn quick without the need for any debugs or anything like that. So the first thing that we absolutely need to make this work is layer 3 connectivity to the AP manager. Remember, we always join to the AP manager on 5246. Actually, I guess it's both to both the management interface and the AP manager, because we discover the management and we join to the AP manager. So I guess depending on which part fell out, we need that. And the port, the CAPWAP port 5246, that's what we need. So it's really hard to validate this. Sorry, and that's UDP. It's always hard to validate UDP connectivity because we don't really have a tool to target a port for a test. TCP is always easy. We can just target the TCP port and establish a session that way. So usually the way I'm just going to validate this is I'll just ping. Can I ping to the controller? So I can either do it from the controller to the AP or from the AP to the controller. Honestly, it doesn't really matter. Either way should just be fine. But for instance, if I'm on LAP2 here, and if I kind of type in the password correctly, ping 10.10.112.10, if that's my AP manager, great. If not, management and AP manager. If I can ping it, I probably have UDP 5246 access as well, unless there's an ACL or a firewall in between me and it. But that's usually not the case. So if I can ping it, I'm going to assume that I have that connectivity working fine. Unless nothing else pans out, then I might come back to this. The other way that you can validate this is look at those AP join stats. If you're not seeing it, either discovery or the join, one of those two, then it's probably connectivity. So if you don't see any discovery requests and you know that the access point actually discovered it, it's probably that. Or if you see discovery requests but no join requests, either it's not trying to join to it, or if you have a separate AP manager interface, then it might be a problem getting to that AP manager interface. So just a simple ping, though, is usually all I need to worry about for this. Next one, AP policy config. So this is where we specify, what type of certificates are we going to accept, MICs, LSCs, SSCs. And we can also specify whether we are authorizing these access points. So let's just go take a look. Back under security, AP policies. Do I have the appropriate checkbox checked? So most of the time we're going to be doing MICs. But if you had this one-off SSC, make sure that the box is checked. Also take a look down on the bottom. Are we set to authorize MICs or LSCs against an auth list? SSCs are always auth, so we always have to have an entry for the AP authorization list for self-signed certificates. So if you are using a self-signed certificate, make sure that it's listed down here. If we have the box down here checked for either MICs or LSCs, then once we have these boxes checked, we have to put a list there. So if I wanted to authorize a MIC, I'd have to choose a MAC address and hit add. And that's only if these bottom boxes are checked. If it's not supposed to be checked, just uncheck it, and then any access point that uses a valid certificate type will work, again, with the exception of the SSC, which always has to have an entry in the auth list. So take a look at this screen, just make sure everything's correct. I'm accepting the correct certificate type. Am I supposed to authorize it? Yes. Okay, if I am, do I have the appropriate entry down in the list below? So that'd be the AP policy to check. Next one, and this is usually not the case, but controller time. In relation to the AP cert. So anytime we validate a cert always has an initial date that it begins being valid and then an end date when it's no longer valid. If the controller time is outside of that validity period, it will not accept the certificate, even if it's set to accept MIC or SSC or whatever it is. So it's almost impossible for this to be a problem with the MIC. As long as your controller is this year, honestly, as long as your controller has a date in this decade, it's fine. Because I believe the AP certs are good usually for like 20 years or something like that. So your controller would have to be like year 2035 or whatever for this to actually be a problem. I don't think we can even set our controllers, at least newer controllers, to a date early enough to make it before. But just check the time on your controller and just see, okay, is it today? That's plenty fine. Ideally, you're using NTP, and then you don't even have to worry about this. Where this can be maybe a little bit more of a problem is if you're using locally significant or local significant certificates, the LSCs, Depending on how you provision the certificate from your CA, maybe you didn't set the lifespan long enough. You set it accidentally for 1 year, and all of a sudden 1 year, the AP has been working fine for a year, and now it's not because the cert expired. So pay attention to that a little bit more with an LLC. Otherwise, just make sure that the time is actually today, and you're totally fine for that. Ideally, again, use NTP. One thing to circle back on that AP policy. So let's say that you did use the self-signed certificate. I remember I was going to tell you this and I forgot. But you lost the hash. If you want to figure out what the hash is, do the debug on the controller and the debug PMPKI enable. Somewhere in that huge thing, it'll actually show you, it'll actually say the hash and then the full string of the hash. That's the only place to really find it. So debug PMPKI enable, look for the hash, grab that, paste it into your controller, and actually make sure you're pasting it into every single controller that this AP could possibly join up to. And that'll get you that one, just in case you lose that. But most people honestly don't have to worry about these because as we move on, there are fewer and fewer APs out there that actually don't have a MIC in them anymore. All right, so there are those. Next one, regulatory domain mismatch. So when you buy an access point, you buy an access point specifically created for a specific regulatory domain. So Americas or Europe or I think Japan might have a separate one. When you look at that model number of the access point, for instance, if I go into one of my APs here, do a show version, and if I can find the model number. So here's the model number, this is 3500. This -A, that's the regulatory domain that access point is made for. In order for this access point to join up to a controller, the controller must support that regulatory domain. Usually where you'd run into problems with this is if you're trying to have one controller support access points across multiple different countries, or you bought something in the US and then you send it over to your remote office over in Germany or whatever it was going to be. We need to make sure that the controller is set to accept the regulatory domain that the access point's on. So where would you see that? That's going to be in the country code of the controller. So if I go to the wireless on the controller, country, here are the country codes supported, and then the regulatory domain is based off of what country codes we have specified. A controller can support multiple regulatory domains at the same time, and that's fine. So right now, US is the default. To change any of this, you do have to turn off your radios. So let me do that, and I can show you how it changes when we select a new country. Yeah, that's fine. Go back down here. So let's go ahead and do Belgium, because why not? I think they're -E. Yep. So I can support anything -A-E. So just pay attention to the code on your AP. Make sure it's in here, specifically for the regulatory domain. Most people don't run into that problem unless you're, again, either you've shipped stuff overseas or you accidentally bought the wrong kind of access point. You bought a -E and you're supposed to be using it in the United States, stuff like that. Number 5, no more licenses. So you just don't have enough licenses to support new access points. That's pretty easy to check. Just look at your license usage in the management, software activation licenses. Look for the ones that's permanent. Should say that's in use. So you can see we have 12. And then you can see how many access points we have. If it was 12, obviously we're out of licenses. You can also see the number of access points here as well. So not too mysterious about that one. One, I guess, lesser known one, if you're using older controllers like a 4400, you can actually run into this issue where you have too many APs per interface or port. I guess actually technically per port. On a 4400, the most APs you can have per port is actually 48. So you can order a model of the 4400 that had 100 licenses, but only two, oh wait, no. Yeah, I think you could get 100 licenses with 2 ports, but basically what you could run into is where if you're running in non-lag mode, you can only have 48 APs joining up to a port. So technically, even though you had enough licenses, it won't join up to the port just because the port can only support 48 access points. The fix there would be to, one, provision more ports if you have more ports available, so you create additional AP manager interfaces and assign them to the additional ports. Or enable lag. Once you turn on lag, you eliminate this 48 port maximum, and you can just have, however many licenses you have, you can use that on the lag. So this is really only on 4400s or the similar models to those. I think maybe the WISMs, the original WISM ones, might have been the same thing because those were essentially two 4400s shoved. But sorry, that's not the case because WISMs were always lagged. So. Usually 4400 is about the only place you run into that one. Just a few more here. AP models not supported. On the WLC code. So every so often as we get new code comes out, older APs become unsupported. So for instance, if you're running current code today, whether it's 7.3 or 7.4 or 7.5, you can't use a 1230. As we march on down the line, I think the newest code, stuff like the 1250s become unsupported. So always check that. Also, if you're using older code, you can't support the newer access points. So if you bought a 2600 or 1600 series access point, but you're running 7.0 code, you're out of luck. So usually you run to this as you're trying to introduce a brand new model of access point. Hopefully you looked at this before, but check to make sure that your AP model is actually supported on the code that you're running. And number 8, with mesh APs, have a few requirements here. Mesh APs, check AP authorization. Mesh APs always have to be authorized. Even if you don't specifically say enable AP authorization, mesh APs are the exception to that. So you have to have an entry in that AP authorization list to allow a mesh AP to join up. Technically, you could also put an entry in the MAC filter list. That works as well. So the two places you could put an entry for a mesh AP, the AP authorization under AP policies. So you just put an entry in here. Again, you don't actually have to say authorized mix. It's going to happen on a mesh AP no matter what. So you can either put it in here, and it's going to be a MIC, or you could go up to MAC filtering, do a new MAC filter entry, just put the MAC address of the AP in there, leave everything else the default, apply. That works as well. Either place will work for a mesh AP. The other requirement on a mesh AP is that a mesh AP will only join up to a controller that has one country code selected. So as we have things configured right now, no mesh AP could ever join this controller because I have 2 country codes. So check that as well if you're having a problem with a mesh AP specifically joining. Only one country code is going to be allowed. And one country code. And last one, and this is a really ridiculous corner case. You have no AP manager. This only could ever happen on a 2500 or 5500, one of those current selling controllers where the management interface can also be the AP manager. Technically, you can turn off the AP management functionality from the management interface. If you don't create another AP manager interface, there's no AP manager, so when it sends, I don't even think it sends back a discovery response, but even if it did, it would have no IP address to put in that discovery response message. So I think it just drops it, honestly. it won't ever send a response back. But to check that, you can just go into the interfaces on your controller. You just need to have something with the dynamic AP management set to enable. As long as you have that, it will send back an AP manager IP address in that discovery response, and everything's fine. So, some of these are going to be, affect 1 or 2 APs at a time. Someone's going to be globally affecting, like if the time was ridiculously off, it would probably affect every single AP. Obviously, the no AP manager would affect every single AP. Some of it may be layer 3, some stuff has layer 3, some stuff doesn't. So you just run through the checklist. So, starting from the top, can I ping between them? Yep, then we probably have it good. If I look at my AP join stats, I should see both requests and responses for, discovery and joins. Look at my AP policy. Am I accepting the correct certificate type? Am I set to authorize it, or is it a self-signed certificate? If so, make sure I have an AP authorization entry for it. Is the controller time right? Is it today? That's usually plenty fine. Otherwise, if I'm using a locally significant certificate, did I provision those certs far enough into the future? If you want to make sure, if you are using a locally significant certificate and you want to check the validity period of that, that's one thing I forgot to mention. Go onto the access point. And it's a command I almost never have to do, so let me make sure I have it right here. Show crypto CA certificates. Show crypto CA certificates. You should be able to find the locally significant certificate in there and then look for the validity date. Just make sure it's appropriate. So there's a number of certs on an access point, so you have to keep on scrolling down until you find the AP's cert, because this also has CAs to validate the controller's cert that it sends back to it. That's where you could find that. Am I using the correct regulatory domain? Just make sure that the model is used for the regulatory domain that you're using. Do I have licenses? If I'm on a 4400, do I have more than 40? Am I running into that 48 ports per 4400? Is my AP model supported on the code I'm running? If it's a mesh AP, make sure I have an auth entry for it. One country code. Make sure I have an AP manager. Not that hard to check most of these, and you could probably burn through these in about 2 minutes time. So, cheat sheet method, you don't have to do any debugs. Just start going down the list. Is it this? Nope. Is it that? Nope. And usually you'll find it pretty quick. If not, then it's time to maybe flip over to some of those debugging options. But this is the way I like to do it, just because I'm not a huge fan of debugs myself. Some people love it. So if whatever method gets you to the end, awesome. You should have the tools that you need, though. Again, so the process, start looking at the logs. Definitely check out the AP join statistics page, where it's going to give you, hopefully an actual error that's going to tell you what the problem is. If you can't figure it out from there, either do the debugging method or the cheat sheet method. If you use the cheat sheet method and you can't figure it out, then maybe fall back to the debugging method. So that is kind of the process I use. Let me give you a couple documents. I'll paste them into the chat window for troubleshooting this join process here. Now some of them are, or at least one of these, the first one that I gave you here is actually a little bit older. It starts talking about LWAP instead of CAPWAP, and it talks, some stuff about, layer 2 versus layer 3 AP join process. So you can kind of filter that out, but it's still giving you, like the debugs, showing you some of that debug output, different cases that you could run across, and most of these that I already outlined here. The other one, the second one, actually gets into a little bit more focusing on that AP join statistics. And I guess for the people that are going to be watching this in the future that don't see what I pasted in, I can paste it in here real quick. Those are the two. But if you just Google like Cisco AP join troubleshooting, you'll probably find both of these in that search pretty high up on the list. So that is the join process. So any questions, I guess, about anything that we talked about here today? I'm thinking maybe the next class I do, we're going to start getting into high availability, so talking about AP failovers, the different methods we have for high availability, the process, validating, things like that. Otherwise, if anyone has any suggestions on topics you'd like me to dig into, I'm definitely open to that as well. But again, this has been recorded, so you should see this in our YouTube channel relatively soon, I would think. So, all right. Yep, no problem, Kyle. So yeah, if anyone has anything, don't hesitate to reach out to me. My email address, jrensink@iPexpert.com. You can also find me on the online study list. I'm monitoring that all the time. Cisco Learning Network, I'm usually on the forums there as well if you have questions. So a bunch of different ways to reach out to me. So anything I can do to help you guys out, don't hesitate. I'm here for your assistance. So thank you guys very much for spending some time with me this morning, and hopefully you guys have a great day, and we'll see you next time.